Oops. Okay, so we just imported the data. Then we have done it last week. We set up data as panel, and as we can see here, this indicates that each year corresponds to a particular observation. And again, it's different than this. Then we run our model as we did last week, and again, what we see is what is it like 45% of change in premiums is explained by independent variables in the model, and when we look at interactions here, we can see that 94 states which banned short-term plans altogether, their premiums are lower than premiums in states that allowed them for 3 months. And again, the way you set up comparison, you leave out reference category. You see, here we have like from banned to 36, but if you look at the data, we have this variable which indicates where short-term plans are 3 months state regulation, and we can like look it up. Let's see. Oops. So in DC, for example, they had regulations where short-term plans are 3 months. And then we check for heteroscedasticity. And again, since distribution of errors doesn't seem to be random, there's some kind of pattern here. Sadly, we do have heteroscedasticity in the model. Then we check for multicollinearity. And uninsured 2017 seems to have multicollinearity since it's way above 5, and share of young adults imputed also have multicollinearity, which means those some independent variables in the model, they correlate with each other. And the way you address multicollinearity, I think somebody made a mistake like that. Somebody diagnosed multicollinearity but did not address it by removing the variable. And the way to address it, you just drop the variable, and then you do multicollinearity check again. And now some like variables kind of looks problematic like post, but it's not 5, so I guess we can live with it. Okay, so let's do Durbin. Okay, we have a question in chat. See. Okay, thanks for letting me know. And then we do Durbin Watson test to check for autocorrelation. Autocorrelation is a situation when your dependent variable actually affects your independent variables. Again, your dependent variable affects your independent variables, and in your like model, it should be the other way around. So the way to do it is to run Durbin Watson test, and for that you need this package LM test. So what you need to do, you need to remove hashtag in line 135, and then put it back again after you run the code, and I give you like 1 minute to do it. Oops. Do you guys have it? Say something if you need more time. No? Okay. So The way to interpret it, and I gave you instructions how to interpret Durbin Watson test is um, we have a value of zero point 0.5. So it means we have a positive autocorrelation. So our premiums affect some variables, some of our independent variables. And I would guess it would be something like let's have a look. Uh, I would guess uninsured. I have like a strong feeling that premiums, the amount of money people pay for their insurance affects uninsured rate. Like the more you pay for your premiums, it is likely more people uh, will be uninsured, and this is why it is a positive autocorrelation. Do you understand what I am saying? The larger the premiums, the more uninsured people we have in the state. It's kind of very simple connection here. And again, if p-value is below 0.05, and we always compare with 0.05, the autocorrelation is likely present. And since we have this p-value with like a lot of zeros, autocorrelation sadly is present in the model, and then we can plot autocorrelation function using this ACF command, and lines, those blue dot lines are confidence level, which indicates, and there is some stuff like below and above it, which indicates there's our confidence level is like is like 95% statistically significant, or even more, I would say. And then we can plot residuals. Uh, and again, it kind of looks like a pattern. We do see autocorrelation. Uh, Again, interpretation of plots is residual plots is really simple. If it looks random, if there is no particular pattern, then we don't have a problem. But if you see some kind of pattern, then we do have a problem, and we do see some outliers in the data. That's about it. Let me